Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 22, 2025, just yesterday. The big hook is that this paper introduces LoongRL, which teaches long context reasoning so well that accuracy on multi-hop questions jumps by 23.5% on QN 2.57b and 21.1% on 14b. The paper is titled LoongRL, Reinforcement Learning for Advanced Reasoning over Long Contexts. And as we will see later, the implications for model training are quite significant. Beyond raw scores, the method uses KeyChain tasks to induce a plan-retrieve-reason-recheck pattern that generalizes from 16K training to 128K inputs, passes all 128K needle tests, and preserves short context skills. So Figure 1 contrasts model thinking with and without KeyChain reinforcement learning data, showing that explicit planning and rechecking lead to correct answers. KeyChain means inserting unique identifier chains that force stepwise tracing before reasoning, which compels disciplined retrieval. The left panel shows a plan, retrieve, reason, recheck sequence that ends correct. The right panel shows mixed retrieval and reasoning without a clear plan, which drifts and answers wrong. So Figure 2 shows how KeyChain training data is built, which matters because the pipeline creates hard but verifiable long contexts. A key value chain means a sequence of unique identifiers that point step by step to the real question. The left panel filters source multi-hop items to keep clean pairs. The lower left panel pads the context with documents to reach long length. The large right panel inserts one real chain and several distractor chains into random positions, forcing precise tracing before reasoning. Alright, Table 1 summarizes the mixed dataset used for reinforcement learning, which balances hard, long context tasks with stability-preserving basics. The KeyChain portion supplies difficult multi-hop questions, and each source contributes 2,500 examples. The retrieval rows are book ruler stress tests, which means synthetic setups that force precise lookup under many distractors. Each retrieval variant includes 512 items. Inputs reach about 21,000 tokens, so the model practices navigation across lengthy contexts while keeping short context skills intact. So, Table 2 compares long context reasoning with general short tasks across many baselines. The headline is that LoongRL at 7b and 14b reaches frontier long context performance while preserving broad skills. The left block lists the multi-hop and narrative benchmarks, where the 14b variant posts about 74 on the long context average. The right block reports MMLU, math, and instruction following, which stay competitive because the mixed training recipe maintains short context competence. So, while Table 2 summarized broad skills, Table 3 shows how training at 16K transfers to much longer contexts. The top block shows the 7B variant improving narrative QA. The right columns track ruler, a diagnostic that stresses retrieval as context length grows, and they stay strong through 128K because the learned plan retrieve reason recheck pattern guides navigation. The bottom block highlights the 14B model, which leads its peers on both datasets. Overall, the table indicates reliable generalization from 16K training without expensive full-length reinforcement learning rollouts. So Figure 3 reports needle in a haystack retrieval across document depths. Needle in a haystack means hiding a single fact inside a very long document and checking if the model can fetch it at any position. The LoongRL 7b panel stays fully green, which signals perfect retrieval up to 128K tokens. The base QN 2.57b and the R1 distilled 7b lose accuracy as depth and context grow because they struggle to locate late needles. Quen Long L132b improves, but still falls short of a clean pass. Wrapping up, two takeaways stand out. KeyChain reinforcement learning reliably induces a plan, retrieve, reason, recheck habit that scales from 16K training to 128K contexts, and the gains rival much larger models while preserving short context skills. The broader implication is cheaper, verifiable, long context training that makes smaller models truly competitive. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.